Welcome back. So, in the previous lesson, we talked about how to graph reciprocal functions. Now, in today's lesson, we're going to talk about translations of these reciprocal functions and how to handle those. So, for translations, hopefully you remember that this down here, whenever the x is shifted, is a horizontal translation. And whenever you're adding or subtracting something from the end, that is going to be a vertical translation or a vertical shift. All right, and those are the two things that are going to shift around your asymptotes. So remember I said in the lesson, in the previous lesson, that it seemed pretty silly to talk about those asymptotes yet because they were always zero. Well, this is where they start shifting. This is where they're not always going to be zero. So what are we going to do? Well, we're going to use those values to find the asymptotes. That's the first thing that we do. Then we're going to find two values, one to the left and one to the right of the vertical asymptote, to plot those points to see where the branches are, and then we just sketch the curve. So let's step through one of these together. So here's our equation, y equals 1 over x plus 1 minus 2. All right, so the x plus 1, that is shifting my vertical asymptote. That is shifting it 1 to the left. Remember, when you see a plus there, is actually shifting it opposite of what you'd expect. So here I'm getting my asymptote at -1. So my domain is going to be all real numbers except x can't be that -1. And again, that's because that would make us divide by 0. And again, you know we can't allow that. So my asymptote is where I would be dividing by 0. Horizontal asymptote. Well, my y is being shifted 2 down. So again, don't forget that's the tricky part, is the shifting up and down occurs just like you'd expect it would. It's only the left and right that are shifting slightly strangely. So I'm going to put that on here too. So my range, again, I noted, is all real numbers except where that asymptote is. Okay, you can't include where the asymptote is in the range. There won't be any values there. All right, so we have our asymptotes now. So the next thing is we need to get two actual points. Okay, so we already know that -1, we already know that's where it's undefined. Okay, we know that we can't use that value. So what I'm going to do instead is I'm going to use one value to the left of it and one value to the right of it, because there'll be actual points there, and that'll tell us where my branches are. So I'm going to plug in -2 to my equation. So I'm going to do my scratch work down here. So I'm going to plug in -2. So that's going to give me 1 over -1 minus 2. So essentially, -1 minus 2, or that is a -3. So I have -2, -3. That gives me a point there. And I'm going to plug in 0. So this time that's going to give me 1 over 1. Well, 1 minus 2 is just -1. So 0, -1. So I find those 2 points, okay, And then all I do is fill it in. I show that from that point, it is approaching the asymptotes forever. And that's actually the end of our problem. So it's quite a bit of new stuff, but in the end, I don't think it's too terrible to figure out. But let's do one more just to make sure that we really understand what's going on. So this x minus 4, that tells me my vertical asymptote is at 4. Again, that minus 4 means it's shifting to the right. It's shifting oppositely of what you'd expect. So at x equals 4, I have my vertical asymptote. And then my domain, again, it's all real numbers, except I can't use that 4. All right, then this plus 6, that is giving me my horizontal asymptote. My horizontal asymptote is being shifted up. My whole graph is being shifted 6 units up. And again, for my range, what that means is I'm getting all real numbers, except I can't use that value. All right, so I have a lot of the work done now. Now I just have to finish and find 2 points. Well, I know I can't use x, or I can't use 4. I know that's going to be my undefined point. So instead, I'm going to use 2 points around it to help me find 2 points so I can sketch my graph. All right, so I'm going to plug in 3. So I'm going to picture plugging in 3 to that equation. So 3 minus 4, well, that gives me a negative 1. 1 divided by negative 1 is just negative 1. Negative 1 plus 6 is going to give me 5. So I have my first point at 3, 5. Now I'm going to plug 5 in. Well, 5 minus 4 gives me 1. 1 over 1 is just 1. 1 plus 6 gives me 7. So I have my other point now, 5, 7. And now that I have both of those points, now I can make my curve. And again, all you do is now you stretch it out following those asymptotes. And that's going to be how you graph these things. Now, there is one last skill that I'm going to show you very quickly. All right, so you can also work backwards. So, looking at this, so, I'm sorry, that should not be the parent function. The parent function should be that. So given the parent function of 1 over x, we want to show how these are transforming, how these are translating. All right? So if I'm given that parent function, and now I have my horizontal and vertical asymptotes given, I can actually go back and I can write the translated equation. Because think about it. If my parent function is 1 over, well, my x needs to be shifted 2 to the right. My y is being shifted 5 down. So all you do is follow the translations. So for this one, to shift to the left, you need to use x plus 3, and then 4 up, you need a plus 4. So basically, you're just using those asymptotes to shift where your function is, okay? So it's just the opposite of what you've been doing when you were graphing, is you're looking at the graph and now saying, where is it coming from? All right, so again, this got to be a little bit longer, but again, I thank you for joining me. Please make sure you have everything written down and come and ask if you have any questions.